Okay, so the question we're looking at now is using the rectangular method to find the curve in the hyperbolic parabola, so to draw it out in elevation. So what we're going to do first is to use what we're given, same as the last question. We're given our plan and we're given our heights in elevation. So we draw in our outer circle, which is going to be the top and the base, and we can mark them in heavy then, and then we can bring up our throat height, which we're going to be given. So then what we do next is we bring up our two lines here and here for the outside of our throat circle, and then we mark off point A, B, C, vertex 1 and vertex 2, so we can divide up this here to get our curve. So how we're going to do that then is we're going to have to divide up this AC here and AB here into equal amount of parts. So I've decided to go with 4 parts for each, and go draw on what we learned in junior cert technical graphics, and we're going to divide up the line into 4 equal parts. So how we do that is we use sliding set squares. We divide this line here, any random line at any angle, into 4 parts, and we bring the last point back to point C, and then from there we use sliding set squares back to each point, as I'm doing here. So now our line AC should be divided up equally into 4 different parts, and then we'll do the same with AB. So any random line up here, and we'll use our compass to split it up into 4 equal parts. So 1, so there's 4 equal parts. So now our next step is to find the lines of the points of intersection so we can draw our curve. We're going to have to bring point 1, 2, 3 and 4, and points 1, 2, 3 and 4. We're going to have to bring the ones between A and C back to vertex 2 on the opposite side. And then the points here come down to vertex 1. So all down to the 1 point. So there are 4 points all brought down. So now we connect point 1 with point 1, the point of intersection. Mark that off, 2 and 2, and 3 and 3, and 4 and 4. And that should give you your curve, your first curve, in this quadrant of your hyperbolic paraboloid. So then, to get the rest of the points and finish off the curve, what you can use is, you can redo this method in each corner, or a simpler way is to bring across the points, and along that line rotate the same distance from the center onto the other side, and you can do that for each point until you have your 4 curves and you've completed your hyperbolic or hyperbolic revolution.